Is sulfur trioxide polar? We should start off answering these questions by drawing the Lewis-Dot structure. And when you draw the Lewis-Dot structure of sulfur trioxide, you find a double bond and two single bonds. This double bond can resonate between all three positions. This means that this double bond is not affecting this symmetry of the molecule. All three bonds are going to be identical to each other. They're going to be a partial, more than a single bond and less than a double bond. So now that we have the Lewis-Dot structure, to answer if it's polar, we have a polar bond between sulfur and oxygen, so we have the potential of it being polar. But is it symmetric? If we have a highly symmetric molecule, it cancels off the poles across the bonds and ends up leaving no dipole across the molecule. So this is a trigonal planar molecule, so it has the potential of being an equilateral triangle, and that's what it could look like to us. So to decide if it's symmetric, we ask two questions. Are the attached atoms the same? We have three attached oxygens, so that is true. Are there no lone pairs on the central atom? And that is also true. The other way of saying this is that the electron geometry and molecular geometry are the same. So it's trigonal planar for both electron geometry and molecular geometry. So this makes it highly symmetric. So this is not polar. It's a three-way tug-of-war between all three oxygens, and neither one of them wins out, so it becomes a non-polar molecule. What has the stronger intermolecular forces? Methane or methanol? And again, it's good to start off with the Lewis-Dot structures, methane and then methanol. And on the methanol, we have hydrogen directly attached onto oxygen. That means that we have hydrogen bonding. In hydrogen bonding, this hydrogen will associate with a lone pair on another oxygen, and then other hydrogens from oxygens will associate directly with these lone pairs here. The methane, though, is a nonpolar compound. It's a hydrocarbon. Hydrocarbons are always nonpolar, so this is a nonpolar compound, meaning that we only have dispersion forces. So obviously hydrogen bonding is stronger than dispersion forces. So our methanol has the stronger intermolecular force because it has hydrogen bonding.